An open ground means the ground wire in the receptacle isn't connected to any grounding point, such as an electrical panel or metal conduit. This means the receptacle is not grounded and cannot provide a path for electrical current to return safely to the panel. The National Electrical Code, or NEC, requires all electrical outlets in residential buildings to be grounded. This requirement applies to both new and existing buildings. Open ground outlets are considered a safety hazard and violate the NEC. Building owners must maintain their buildings in compliance with the NEC. This includes repairing or replacing any electrical defects, such as open ground outlets. Once a building owner is aware of a code violation, they must take steps to correct the problem within a reasonable time frame. While older buildings may have some exemptions or grandfather clauses, these exemptions do not apply to safety hazards like open ground outlets. Building owners are still required to correct these issues to ensure tenant safety. Firstly, contact the landlord again. Explain the issue and the safety risks involved. Provide them with information regarding open grounds and request that they fix the problem immediately. Secondly, contact the local building inspector. If the landlord refuses to address the issue, contact the local building inspector. They can inspect the property and issue a violation notice if necessary. Thirdly, install ground fault circuit interrupters, or GFCIs. While not a permanent solution, installing GFCIs can help protect from electrical shocks in the event of an open ground. Open grounds are dangerous because they eliminate a crucial safety feature designed to protect individuals from electrical shock. In a properly grounded electrical system, the ground wire provides a low impedance path for fault current to flow back to the source. This allows the circuit breaker or fuse to trip quickly, cutting off power to the circuit and preventing electrical shock. Without a proper ground, a fault current can energize the metal parts of an appliance or electrical equipment, creating a shock hazard if someone touches it. The absence of a ground connection also makes electrical equipment more susceptible to damage from power surges and voltage spikes. Surges can damage sensitive electronic components, shortening the lifespan of appliances and potentially causing fires. Grounding provides a stable reference point for voltage, helping to suppress voltage fluctuations and protect equipment. The NEC is a comprehensive set of standards for safe electrical installations. It's updated every 3 years to incorporate new technologies and address emerging safety concerns. The NEC covers everything from wiring methods and overcurrent protection to grounding and bonding requirements. Its primary goal is to safeguard people and property from electrical hazards. The NEC grounding requirements are very specific. They outline how to properly ground electrical systems and equipment to minimize the risk of electrical shock and fire. The code specifies the types of grounding conductors that must be used, the methods for connecting grounding electrodes, and the requirements for bonding metal parts of electrical systems. When a building owner is notified of an NEC violation, they are legally obligated to take corrective action. The time frame for correcting the violation may vary depending on the severity of the issue and local regulations, but prompt action is essential to mitigate any potential hazards. Ignoring code violations can result in fines, legal action, and liability for any damages or injuries that result from the unsafe condition. Grandfather clauses typically apply to aspects of a building's electrical system that were compliant with the code at the time of installation. However, these clauses generally do not extend to conditions that pose an immediate safety hazard, such as open ground outlets. Safety-related violations must be addressed regardless of the age of the building. A GFCI is a life-saving device that detects ground faults and quickly interrupts the flow of electricity to prevent electrical shock. It works by monitoring the current flowing into and out of a circuit. If there is a difference of even a few milliamperes, the GFCI will trip, cutting off power to the circuit in a fraction of a second. GFCIs are particularly effective at preventing electrocution in wet or damp locations, such as bathrooms, kitchens, and outdoor areas. While GFCIs can provide a significant level of protection in the absence of a proper ground, they are not a substitute for grounding. GFCIs only protect against ground faults, which are just one type of electrical hazard. Grounding provides broader protection against other types of electrical problems such as voltage surges and equipment damage. In an apartment building, the building owner is ultimately responsible for ensuring that the electrical system is safe and compliant with the NEC. This includes hiring qualified electricians to perform inspections, repairs, and upgrades as needed. Tenants have a right to a safe living environment, and they should not hesitate to report any electrical hazards to the landlord or building management. If the landlord fails to address the issue, tenants can contact local authorities, such as the building inspector or fire marshal, to request an inspection and enforcement of the code. The voltage of 126.7 volts is higher than the nominal voltage of 120 volts typically found in residential circuits. While a slight voltage variation is normal, consistently high voltage can put stress on electrical appliances and shorten their lifespan. Prolonged exposure to high voltage can cause appliances to overheat, malfunction, or even fail prematurely. It's important to have the building's electrical system inspected by a qualified electrician to determine the cause of the high voltage and ensure that it is within safe limits. An electrician can check the voltage at the main electrical panel and at various outlets throughout the building to identify any potential problems. They can also inspect the wiring, transformers, and other electrical components to ensure that they are functioning properly. If the high voltage is due to a problem with the utility company's equipment, the electrician can contact the utility to request repairs or adjustments. If the high voltage is caused by an internal wiring issue, the electrician can make the necessary repairs or upgrades to correct the problem. In addition to addressing the open ground outlets and the high voltage, it's also important to ensure that all electrical circuits are properly protected by circuit breakers or fuses of the correct size. Overcurrent protection devices are designed to trip and cut off power to a circuit if the current exceeds a safe level. This prevents overheating and potential fires. It's essential to have the electrical panel inspected to verify that all circuit breakers or fuses are in good condition and are properly sized for the circuits they protect. If any circuit breakers or fuses are tripping frequently, it could indicate a problem with the wiring or an overloaded circuit. An electrician can investigate the cause of the tripping and make the necessary repairs or adjustments. It's also a good idea to install surge protectors to protect sensitive electronic equipment from power surges and voltage spikes. Surge protectors can be plugged into electrical outlets or installed at the main electrical panel. They divert excess voltage away from electronic devices, preventing damage from surges caused by lightning, power outages, or other electrical disturbances. There are three main components to electrical safety. These include grounding, overcurrent protection, and surge protection. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip quickly and prevent electrical shock. Overcurrent protection devices trip and cut off power to a circuit if the current exceeds a safe level, preventing overheating and potential fires. Surge protectors divert excess voltage away from electronic devices, preventing damage from surges. When dealing with electrical issues, it's always best to consult with a qualified electrician. They have the knowledge, experience, and tools to diagnose and repair electrical problems safely and effectively. Attempting to fix electrical problems without proper training can be dangerous and could result in electrical shock, fire, or other hazards. A qualified electrician can inspect the electrical system, identify any potential problems, and make the necessary repairs or upgrades to ensure that it is safe and compliant with the NEC. They can also provide advice on how to improve electrical safety in the building and protect against future problems. The absence of a ground also could affect equipment. Without a proper ground connection, static electricity can build up on the metal parts of electrical equipment. This static electricity can discharge unexpectedly, causing damage to sensitive electronic components or creating a shock hazard. Grounding provides a path for static electricity to dissipate safely, preventing these problems. In addition to the safety benefits, proper grounding can also improve the performance and reliability of electrical equipment. Grounding helps to reduce electrical noise and interference, which can affect the operation of electronic devices. It also helps to stabilize voltage levels, ensuring that equipment receives a consistent and reliable power supply. The NEC specifies the types of grounding conductors that must be used, the methods for connecting grounding electrodes, and the requirements for bonding metal parts of electrical systems. Grounding conductors must be made of copper or other approved materials and must be sized according to the size of the circuit conductors they serve. Grounding electrodes must be installed in accordance with the NEC and must provide a low impedance path to ground. Bonding is the process of connecting metal parts of electrical systems together to create a continuous electrical path. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. The NEC requires that all metal parts of electrical systems, such as metal conduits, metal enclosures, and metal equipment frames, be bonded together. Building inspectors are responsible for enforcing the NEC and ensuring that electrical installations are safe and compliant with the code. They conduct inspections of new construction and existing buildings to identify any code violations. If a building inspector finds a code violation, they will issue a violation notice to the building owner. The violation notice will specify the nature of the violation and the corrective action that must be taken. The building owner must correct the violation within a reasonable time frame or face fines or other penalties. Building inspectors also investigate complaints from tenants or other individuals who suspect that there are electrical hazards in a building. They have the authority to enter a building to conduct an inspection and to issue violation notices if necessary. Local authorities, such as the building inspector or fire marshal, can enforce the code if the landlord fails to address the issue. GFCI outlets can provide a significant level of protection in the absence of a proper ground. Electrical systems must meet the requirements outlined by the NEC for safety reasons.